Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Mstat, and CMI MSc Data Science.
This is the first question. Please ignore the answer part. Just look at the question. So here we are basically given four matrices A, B, C, and D, and we need to check which of the following matrices is not diagonalizable over R. So let me show you the solution. So any given matrix is diagonalizable over R if it has distinct eigenvalues. So let us obtain the eigenvalues of the given matrices. Let me show the matrices first. In part A, you can observe that a matrix is upper triangular, since all the lower triangular elements are equal to 0, and the eigenvalues of an upper triangular matrix are equal to its diagonal elements. It's a property, and it's similar for the lower triangular matrix as well. And even in part C, it's a upper triangular matrix, so the eigenvalues are again the elements in the diagonal. So you can observe here 2, 3, and 2 are the eigenvalues, where 2 and 2 obviously occur twice, and these hence the eigenvalues are not distinct. And in part C as well, 2, 3, and 3 are the eigenvalues, and 3 occurs twice. So again, they are not distinct. So obviously you can see that A and C are not diagonalizable. Now let's check options B and D. I've written on the same thing here, that in both A and C, they are upper triangular, so the eigenvalues are the diagonal elements. In part B, the eigenvalues in general of a matrix are given by solving the equation determinant of I minus A minus lambda I is equal to 0, where A is the concerned matrix and I is the identity matrix. So we have A minus lambda I here, and we have equated its determinant to 0. So by just by obtaining a determinant, we can observe this is 1 minus lambda square minus 1 is equal to 0. So 1 minus lambda is just plus minus 1, and lambda is 0 and 2. So the eigenvalues are distinct. And in D, these are given by this equation. We can move here. I have simply written them down in terms of just obtain a determinant, and the lambda comes out to be 2 and 3. So even in both in B and D, the eigenvalues are distinct, and hence both B and D, the eigenvalues are distinct, and hence they are diagonalizable. And options A and C, they are not diagonalizable. So A and C are the correct options. For example, let me just try this matrix. For example, let us consider this matrix 0, 0, 0, 1. Now, obviously, this matrix is not invertible, because this matrix has determinant equal to 0. The first row is 0. So determinant is 0. So it's not invertible. But the eigenvalues are 0 and 1, which are the diagonal elements. So this matrix is diagonalizable because the eigenvalues are non-distinct. Sorry, that they are distinct. So here we are given two CDFs, F1 and F2, and we need to check which of the following. We are given three options, and none of the above option, and we need to check which of these are DFs. So in the first option says F is alpha F1 plus 1 minus alpha F2. The second option says F is 2 F1 F2. Third one says it's a function of F1 and F2, 1 minus 2 F1 and 2 minus F2 by 2. Here we are given two CDFs F1, F2. And in part A, which is the convex combination we're talking about, it is right continuous, since it's a linear combination of F1, F2. And for similar reasons, it's monotone non-decreasing as well. And I just put the limits at infinity. So it comes out to be alpha plus 1 minus alpha, which is 1. And at minus infinity, it's alpha into 0 plus 1 minus alpha into 0, which is 0. In part B, you remember it's f is equal to twice f1, f2. So we just put the limit at x equal to infinity, and it comes out to be 2, which is not equal to 1. So obviously B is not a CDF. And in part 3, I put done the same thing and it comes out with 3 by 2. So C is not a CDF as well. Therefore, A is the correct option.
We give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists.